Okay, so in the previous video, we talked about two types of energy. We talked about kinetic energy and we talked about potential energy. So we said that kinetic energy is energy of motion and potential energy is energy that's stored. So one thing that we need to know about those two types of energy is that they can be changed. So we have this super important law called the conservation of energy, probably one of the most important laws in physics. And it tells us that energy cannot be created nor destroyed. So when you eat your food, it had potential energy stored. The energy isn't gone, it's transformed. And when we talk about transformed, another way to say the word transformed is to say changed. So when your bagel was sitting on the table, it was stored energy. It was potential energy stored in that food. When we put it into our bodies, we don't need the stored energy anymore. Our bodies are eating so that we can walk and we can talk and we can keep ourselves warm. So we're changing that stored energy into energy that we can use. The same thing happens on a roller coaster. You have the same amount of energy at each point, but if you've ever been on a roller coaster, you know that sometimes you're moving slowly and sometimes you're moving quickly. So if we're looking at this roller coaster here, we want to know where does it have the most potential energy and where does it have the most kinetic. So we know that kind of up at the top, we're going pretty slow. And so this is going to be where it's got the most potential to fall. But since it's moving slow, it's going to be low kinetic energy. Now, as we move down, it speeds up, and kind of at this lowest point is where we're going to have high kinetic energy. We're moving really, really fast, but we're really close to the ground at this point, so we're going to have low potential energy. So at that point, we haven't lost the energy. We've changed it from the potential that we had up at the top to the kinetic energy that we have down at the bottom. So again, you guys, we don't use up energy, we just change it into different things. One of the energy transformations that we see often is mechanical energy, and this has to do with things that are kind of moving. So mechanical energy is the sum of the kinetic and potential energies. So when we take a sum mathematically, that's when we add them together. So mechanical energy is the kinetic energy plus the potential energy. And this is going to stay constant throughout the whole process. But at any given point, we might have high kinetic energy and low potential, and then they might switch. So a good example of this is swinging. So this student here up at the top has a lot of potential, but think about at the top of your swing, you slow down, almost stop, or you do stop, before you switch direction. So they've got a lot of potential, but they're stopped, so they don't have any kinetic. As you move down, you start going faster. So they're still off the ground, so they still have some potential, but they're going much faster. Down at the bottom, she's got a little bit of potential energy because she's not on the ground, but she's pretty low. But at the bottom point, you're going really fast, so the kinetic has gone up. And then the same thing is going to happen as you go back up on the other side. So in mechanical energy, you have the same amount of mechanical energy, but sometimes you have a lot of potential and other times you have a lot of kinetic. There are many other types of energy transformations or energy changes that happen. So when we look at energy transformations or energy, we have things like thermal energy, which is heat. Light is energy. Sounds require energy. We've got chemicals stored in bonds, mechanical, like we just talked about, and electrical energy, just to name a few. So the thing that we need to remember with energy transformations is that energy is never destroyed, it's just changed. We're not going to run out of energy. We just sometimes change it into things that are not as useful. So for these ones, we want to talk about what type of energy did we start with and what did we end with. So here's my question for you. If no energy is lost, so remember, law of conservation of energy, why does the girl eventually slow down? So if you swing and you don't keep pumping, you don't keep putting energy in with your legs, why do you eventually slow down and stop? So the energy starts as mechanical. We're moving back and forth. We've got our potential and our kinetic. and it's transformed. So think about when you're on a swing. Looks like she's on like an old metal swing set here. Some of the things that happen. I hear sounds. Sounds do not help us swing, but it is energy. So it's maybe not something that I want, but it's going to happen. The sounds are coming from the rubbing that's happening of my metal chains and the clinking. We know that rubbing things together causes friction, and friction causes heat. So some of that energy is transformed to heat as well. So we've got that motion, but we also have things like sound and heat that don't help us move anymore. So sometimes energy transformations are helpful, and sometimes we get transformed into types of energy that are not as helpful. Let's look at another example. So in this case, we want our light bulb to lighten up. So in this picture, we're putting electrical energy in. So we're starting as electrical energy. And once we plug our light bulb in, we get light out of it. So it's transforming or changing from that electricity that's flowing in to light, or we can call that radiant energy. This is a helpful transformation. Now, we also know that sometimes light bulbs get warm, so we might be transforming some of that energy into heat as well, which is maybe an unwanted transformation that kind of wastes some of that electrical energy. Okay, another example. So when we're going to start a fire, we need to put wood into our fire pit. So the wood is going to be our fuel, and anytime we're starting an energy transformation with fuel, we're starting as chemical potential energy. So the bonds stored in our wood. This is going to transform to what we see. We've got radiant light. We've got heat, and if you've ever sat outside with fire on a cold night, we also know that there's some sound. So the majority of our energy is transforming into that light and heat, but we are kind of using some of that energy for sound. Again, remember, you guys, we're going from that chemical potential to these things. We're not losing it, we're changing it into other forms. Okay, one more example here. We probably do this every night or every morning. In order to get our phones to charge, we have to plug them in. So anytime we plug something in that's starting as electrical, we're using electricity. And then we're transforming. So think about all the things your phone does. It lights up, so you're getting some radiant. It buzzes and moves, so you're getting a little kinetic energy. For sure, think about after you use it for a while, the battery pack gets hot, so we're getting some heat. What are we missing? Sound, that's the whole point. Listening to conversations or videos or music. So we're starting with that electrical energy that's stored in the battery, and then we're transforming it into all of those different things. So just kind of as a refresher, you guys remember these energy transformations, we are conserving energy. So we're not using up the electricity, we're changing it into other things that are not as helpful necessarily.